Hi everyone. In this presentation, we're going to look at what exactly are data models, why they are needed, and what kind of data models are out there. So let's get started. So the first thing to note is that all organizations have two types of data. There's the data that can be calculated or computed from existing data, but then there's also the data that needs to be input. Now this data that needs to be input must be stored persistently and be retrievable in order for the organization to run. So we have to store this data on the hard disk, which is also called secondary storage. Now, all computer operating systems offer a file system as a way to store information in files on the hard disk. So the first question we can think about is why not just use files to store our company's information that we need to store persistently? So we could have a separate file for customers, a separate file for employees, and so on. So there are certain issues with this, and the biggest issue is that if we followed the file model, just the flat file model, then we would have to write a lot of code to do things like making sure that data is formatted properly, that data represents what's out in the real world, that there are checks out there for this data, and even linking the data between files. So there will be a lot of coding that will need to be done for every application. And this would make it basically untenable in this day and age for an organization to use simply a file system to store its persistent data. So now let's take a look at what kind of data models have evolved. So before we look at data models, let's take a look at all the things that a data model can do for us over and above the file system that we talked about. So the first thing is, how do we represent the data? So we have information out in the real world that needs to be input, but how exactly are we going to represent this information? Is it going to be in the form of tables? Is it going to be in the form of classes? So we're not really sure, right? So we need to see how is data going to be represented. Next, you have relationships between the different data items. So for example, we want to know which customer took part in which sale, which products were involved in that sale, which employee managed that sale. So how do we link all the information, all the data? That also needs to be captured in the data model. And once we have the information input, then we need to be able to get useful business intelligence out of this data. So there might be some computations that need to be done. There might be some reports that need to be made. There might be dashboards that need to be made. So how do we take the information that's in there and query it? Do we need to go to our IT department and ask them to make us a custom dashboard or write us a program, or are there other ways that the data model offers that allow us to get business intelligence out of it? And lastly, as we add more and more data into our system, we want to make sure that it continues to represent a faithful view of the reality out there. In other words, we don't want the data quality to degrade over time. So many data models offer checks and balances right at the time when we design the model so that there is data quality as the database is used over time. And this is really important because, as we know, we need to have good data quality in order to get good business intelligence out. So with this framework in mind, let's take a look at some common data models out there. So the 800-pound gorilla in the room when it comes to data models is the relational model, which has actually been around since 1970-71, which in computer science time is really long. Now let's see how data is represented in the relational model. So the word relation pretty much means table. So data is represented in tables and columns. So you could have a table for customers and a table for employees and a table for sales. And then the columns in each table would represent the properties or the attributes of the customers or the employees and so on. Now, how is data linked to each other? So in this model, you have key columns that are shared across tables. So for example, the sales table may have a column called employee ID, which basically represents the employee who managed that sale. So each row, of course, is going to be one sale. and the employee ID in that row is going to be the employee for that sale. Similarly, you might have another column called customer ID for that table, for the sales table, and that would represent the customer who was involved in the sale. Let's talk about getting information out for business intelligence. So I might want to know things like who are my best customers for this quarter, or which zip code do I sell the most, right? So information like that can be retrieved using structured query language queries. So SQL has been evolving for the last 40 years and is a very stable language. It allows us to easily build reports and dashboards and to basically answer questions in an ad hoc fashion, meaning we don't have to write computer code to actually get business intelligence out. So that's a really big advantage of relational models. It's also important to know that relational models are primarily used for alphanumeric data, which would be data that involves letters and numbers and so on, which still represents the bulk of the information that we use out in the real world. At least for decision making. Now, in terms of data quality, there's several different concepts that exist in the relational model. First is the concept of primary keys that we may all heard of. And a primary key is essentially a column or a bunch of columns so that the value in each row is unique for that column. So that ensures that every row is basically unique in your table. Foreign keys are basically the key columns that we talked about. Those would be the foreign keys that are shared across tables. Check clauses would be the addition of extra constraints on different columns. So for example, the salary column, we can constrain it to be at least $8 an hour and so on. The GPA column could be constrained to be at least, I guess, 1.0 or 0.0. So there's different constraints you can put on columns to further check what goes into each column in the tables. And then lastly, there's this really powerful concept called triggers, which is not really part of the relational model, but it comes with all relational systems. And triggers are basically code that we write that executes every time we create information or we modify information in the tables or we delete information in the tables. So that is a really powerful mechanism to ensure data quality. But in general, the main concepts that come with the model are primary keys and foreign keys. And these by themselves are actually pretty powerful if properly used in terms of determining good data quality as time goes on. Okay, the next model we're going to talk about is the entity relationship model, also called the ER model. And this came out in 1976, which is about 5 years after the relational model. Now, in this model, we do not represent data using tables and columns. Instead, we have diagrammatic constructs like boxes for entity sets, which would basically be a box with a bunch of objects in it. And each box has a set of attributes that go with it that describe each entity in the box. In terms of relationships between boxes, you have this concept of relationship sets explicitly drawn as diamonds. And we don't use common columns here. Instead, we actually draw the diamond between the boxes to show the relationship. This model was not actually developed or evolved on computer systems and is not really used nowadays to store data or to retrieve data. So we don't really have any querying mechanism for getting business intelligence out because it's not really used to store or retrieve data on computers. So what is the purpose of this model? Why is it so popular? Well, this model has turned out to be a really great intermediate step when it comes to getting user requirements in a natural language like English, let's say, which tends to be subjective, right? And drawing a sketch using these ER diagrammatic constructs. And if properly drawn, this ER diagram or ER schema can actually make the design of our database a good design. And with a good design, we can ensure better data quality. So a typical methodology is to take the user descriptions and create ER schemas out of them or ER diagrams, and then map the ER schema to tables. So this model is really helpful in terms of ensuring data quality of relational models. So the next model we're going to talk about is essentially an evolution of the ER model, and it became known as the extended ER model or the EER model. And this went on into the 1980s. So essentially what people found was that the ER model, while being really helpful, was not nuanced enough in terms of just having entity sets and relationship sets and attributes and primary keys. It just wasn't enough to take out the nuanced descriptions that existed in natural languages like English. So more concepts were created. So apart, of course, from the entity sets and the relationship sets, there were other concepts that were created, like, for example, weak entity sets. So a weak entity set is nothing but an entity set whose members or entities depend for their existence on other entities in a different box or a different entity set. Subclasses, which were basically groupings within entity sets that have further specialized attributes and or specialized relationships. Multi-valued attributes, so an example of subclasses might be like we have students as a class and then or an entity set, and then a grouping within that might be, let's say, graduate students who have specialized attributes like their undergrad major and so on, their undergrad GPA, and so on. We have multi-valued attributes, which would be where one entity could have multiple values for an attribute, like for example, customer email. There could be multiple values for it, so that would be a multi-valued attribute. We have composite attributes where the attribute can be further split into component attributes. Like for example, your address could be further split into your street information and your state and zip code and so on. So essentially the ER model is what most people use nowadays when it comes to serving as a stepping stone between the end user requirement and the relational sketch. The relational sketch would be the listing of the tables and the columns and the primary keys and the foreign keys, but the intermediate step would be an EER sketch. And once again, the ER model did not really develop on computer systems. So it's not really used for storage or retrieval of information. So there is no query language that makes sense for the ER model. Data models have continued to evolve. So the ER model and the relational model sort of still represent the bread and butter of data models. And for most organizations, they are more than sufficient. However, in the 2000s, companies like Google, Amazon, and Facebook began to grow and have massive amounts of data that they needed to process. So for these companies, the relational model is just too slow in terms of being able to retrieve massive amounts of data in real time. For example, a weblog where you have millions of web hits every hour, and you need to store that and retrieve all the web information for a particular customer, for example. So different data models came out. So Google, for example, came out with a columnar model. There's the key value model that is used to store information in terms of key value pairs. And then there's graph models that will be used to store information that connects people, let's say, in a social network. So for each of these models, the data representation is obviously different. For columnar databases, it's column families. For key value databases, it's key value pairs where the keys are the way that you retrieve the data, but the values tend to be opaque and you can't really get to them. And then there's the node edge method of representing data in graph models. The relationships between data where you want to show, those usually have to be written in code. In some cases, of course, you can have key values that may be used, but in general, the relationships are managed in code. Querying for business intelligence, again, there's no real language that exists for these systems to draw or to come up with queries quickly. They have to be coded. And for data integrity, there's very few constructs. So these are specialized systems where most of the data that's being input is automated. It's coming from other computer systems like the web browser and so on that is writing to the database, the web server, not the web browser, sorry, that is writing to the database. Um, so there's no real need for data integrity as such because there's very little possibility of human error. And so the main reason for these systems is their sheer speed of storing data and accessing it. You can do it in basically in real time. So these systems remain specialized, and once again, they continue to evolve. But again, it's important to keep in mind that the bread and butter of data modeling is still the ER model and the relational model. So before we go further, it might be important to understand the difference between a data model and a process model. So every organization has both data and processes. So the processes would be the activities that the roles or the people in the organization do, right? And if you talk to someone and ask them what they do, they're not going to tell you what data they use. They're going to tell you what things they do, what activities they perform. Now, obviously, many of these activities would use data, and some of them would create data. They would maybe query data and so on. When we want to sketch the activities or draw the activities or document the activities that people do, then you have concepts like sequencing where you list the activities and show the sequence. You have concepts like branching where you show conditional branching when you come to a point in your process. You have things like looping where you do the same thing again and again till a certain condition is met. So all of these concepts, it's important to understand, are used in process models. They're not used in data models. So example process models would be like flow models. So words like flow or process or activity or transition, if that shows up in your model title, then it's most likely a process model. There's tons of process models out there. There's activity charts, there's data flow diagrams, and so on. Data models are different. Data models do not capture processes except to list out the data on that we want to capture. So in a sense, the data model is describing a snapshot or a picture of the organization at any point in time. So our goal when we come up with a data model sketch, let's say an ER model sketch, is to come up with a snapshot of the application or it's also called the domain based on the requirements, right? We want to come up with a sketch that captures all the information that would be needed. Now the requirements are most likely going to have a lot of processes described in them. And our job is to sort of cut through the process speak and try and figure out what data is needed for each process. And then simply document and list the data without worrying too much about the actual sequencing, branching, looping, and all that that happens in the process. So bottom line here is there's process models and there's data models and they are different. So what have we learned from this presentation? We basically learned that data models are necessary abstractions that are needed to capture data and be able to convert it into useful information. And when I say useful information, that means we need good data quality. The 800-pound gorilla or the dinosaur, take your pick, is the relational model. And all of these data models are implemented in software. And each model has a lot of algorithms and schemes associated with it. And the relational model has, for example, concurrency control schemes, durability schemes, uh, query optimization schemes, and so on associated with it, all of which have a lot of algorithms. And all of this means that the relational model has evolved over time to become pretty quick. Now, NoSQL models offer faster retrieval and querying, but they lack data quality checks. And that may not be needed for them because often they're used in very specialized applications where the data input is automated. So having done this, let's think of a fun activity. Let's say you want to start a coffee shop in your local area and you need to think about what data you will need for this. How will you go about collecting the requirements, and what kind of data model do you think you would use? Hint, you'll probably end up using the relational model, but what kind of process do you think you'll go through in terms of making sure that your data quality is good? Thanks for listening, and we'll see you soon.